Assalamualaikum warahmatullahi wabarakatuh. So today we're going to discuss about the fluid system. So what is a fluid system? Basically there's two types of fluids, which is incompressible fluid, basically is a liquid, and another one is a compressible fluid, which is a gas. So basically this is four variables that commonly used in the fluid system, which is a QM, stand for mass flow rate, and then a QV for the volume flow rate, and then H is the fluid height, P is the pressure. Similar to the other system, a fluid system also consists of law of conservation as well as law of property. Basically, this is a typical symbol that used in the fluid system, where we got a resistance, a manually adjust valve, actuated valve, ideal pressure source. This is ideal flow source, and then this one is for a pump. So for the conservation of mass, m dot is equal to QMI minus QMO. QMI is a mass inflow rate, and then QMO is mass outflow rate. Okay, so you also need to know this formula, which is M equal to rho V, which is M mass equal to rho is density, V is the volume. For the conservation of volume, V dot is equal to QVI minus QVO. QVI is the volume inflow, and then QVO is the volume outflow. Okay, let's look at an example. In this example, you've got the QMO, which is outflow of the mass, and then QMI, which is inflow of the mass, and you need to determine the height, which is HT. Right, so first of all, you have a formula where m dot is equal to QMR minus QMO. And then you also know that the formula of M equal to rho V. Okay, and then the volume for this case is P is equal to A H. Right, so you replace, you insert this equation. Let's say this is equation 1, this is equation 2, this is equation 3. So you insert in 1 in 2, so you can get M equal to rho A H, right? So H here is H in terms of T. So you want to put in one side, so you can get H equal to M over rho A. Okay, after this, so from this equation 3, you can get M should be equal to integration of QMI minus QMO, right? So you insert this into equation into here, so you can get H actually equal to 1 over rho A integration of QMI minus QMO. So this is basically your answer. Okay, now we look into another example, which is a hydraulic brake system. So in here you're going to find the relationship between F4, which is input, and then the F3, which is the output. Right. So if you look into this part, you can draw a free body diagram. Right. Free body diagram like this. Okay, you got theta. Then the F1 is this way. The distance from here to here is basically the same as the x1. So basically this distance is x1, and then the distance from here to here is f4, right? So from here you can see. Let's assume the distance from here to here is a y, and then the distance from here to here is r. Okay, and then from this triangle you can see the sine theta should equal to f4 over y, because this one is a 90-degree angle here and as well as a 90-degree angle here, right? So if you find sine theta, the f4 over y as well should be equal to x1 over r. Alright, so if you look at this part, you can observe that the volume that exits from this chamber is equal to volume that inflow in this chamber. A1 x1 should be equal to A2 x2, right? Because x2 is the area, A2 is the area for this chamber, and then the A1 is the area for this chamber, and then the x1 is the distance traveled by this piston, and then x2 is the distance traveled by this piston. Alright, so you got equation 1, you got equation 2. So in this part, you can see that the F2 L1 should be equal to F3 L2. Okay, so basically this one is your equation number 3. So in here you got F3, your output, right? So you put F3 in one side, so it should be equal to F2 L1 over L2. Force is actually equal to pressure time with the area, P over P times A, right? So if F2 should be equal to P2 times with A2, right? So with this information, you can insert the equation number 2 here into this equation, right? So when you insert in equation number 2, you got F2 should be equal to P2 A1 x1 over x2, right? So you insert this one, the whole thing here, into the equation number 4 here, equation number 4. So where you got the F3 should be equal to P2 A1 x1 L1 over L2 x2. So you already know the x1 from the equation number 1 here. X1 is actually equal to F4 R over Y, right? So if you move R over there, so you insert this one into this equation, you can get P2 A1 x1, you replace with F4 R and L1 over L2 x2 over and Y. So this is basically your relationship between output. This is the output, and then the F4 is your input. Okay. Okay, this is the example. In this example, it's actually similar to the first example. M dot is actually equal to QMI minus QMO, and then H in this case is M equal to rho V, then V is actually equal to A H. Right, so you find this relationship and then you rearrange that. H equal to M over rho A. If you integrate both sides, so you can get the 1 over rho A integration of QMI minus QMO. Okay, that similar to the first example. So now we go for the law of properties. We have fluid capacitance as well as a fluid resistance. For fluid capacitance, fluid capacitance is actually dm over dt here, right? We get dm over dt is actually the capacitance for the fluid, right? And then if you insert into this equation, you can get c dp over d is actually is equal to qmi minus qmo. So if you do the analogy between fluid and electrical system, for the fluid system, you've got the fluid mass. In electrical, is equivalent to a charge. If you talk about the flow rate, mass flow rate, you talk about a current basically. Then pressure is equivalent to voltage. Then resistance actually is equal to same electrical resistance as well. But the formula is different, right? So heat resistance is actually equal to P over Pm, and then for electrical resistance is actually V over I. For the heat capacitance, actually M over P, or just now we talked about the M over dP, right? And then electrical capacitance is actually Q over V. Heat inductance, uh, yeah, I is equal to P over dTm over dt. And then for electrical inductance is actually equal to L or equal to V over di over t. Alright, so let's see an example. In this example, you need to derive the capacitance. In order to derive the capacitance, you know that the capacitance actually is equal to the N over the P. P is pressure. So what you need to find, actually, you want to find mass in terms of P, right? In the function of P. You can, okay, you can represent this equation. Rho is actually equal to E over GH. And then you insert this in here, right? So then you can get N actually equal to P A H over GH. Then you can get out H, then you can get N equal to PA over G. But in this example, you put the other way around, but it's okay, right? So because at the end of the day, you want to find N in terms of P. Okay, but A here it depends on the shape that you have, because if you have a circle, A actually for a circle is actually equal to 5 R square, right? Then if you got a square, then you can get A for a square, and get if you denoted this one with the X, 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 right? So it depends on the A. But if you want to find C is actually the M over dP. So what you need to do, you need to differentiate this equation. Okay, this is, let's say this is equation 1. So you need to differentiate of equation 1 over dp, right? So what you can get is actually A over G. So basically C is actually equal to A over G, similar as example answer that. Okay, so now we look into another example where we got a container here. We need to derive the capacitance of the container, and then from here we know that the volume for this container is actually is equal to volume is equal to A x dx, where is the integration of from 0 to h, right? So basically the h is changes with time basically, right? So when you try to calculate the C, which is a capacitance, you already know the capacitance is equal to the M over the dP. Pressure is actually is equal to rho GH, rho GH, and then H is actually is equal to rho G. H actually is equal to V over A. Right, so P, you got a P rho G V over A. the dp over dt, but basically what you want to find here is actually you want to relate the m dot with dp, right? dp over dt. That's the relationship that you want to find. So that's why we find dp over dt here, where dp over dt should be equal to dp over dh times with dh over dt. Right, dp over dh, you need to differentiate this over dh. So dp over dh should be equal to, if you insert the volume equation here, so this one you insert here, alright, so you can get p equal to rho g over a integration of from 0 to h a d x dx, right? X dx, right? So you can set out a, so you can get integration of rho g x dx from 0 to h. So if you find if you want to find a dp over dh, then you can get equal to rho g. Then you insert this one. Let's say this is equation 2, this is equation 1. So you insert 2 into 1, so you can get dp over dt is actually equal to rho g dh over dt. So this one you insert into the m dot, right? Because the m dot is actually is equal to dm over dp times dp over dt, right? dm over dp is actually c, and then dp over dt is this the whole equation here, which is rho g dh over dt. And then this one should be equal to qmi minus qmo should be equal to c rho g dh over dt. So this is basically your answer. Okay, let's look into another example. In this example, you need to calculate the capacitance for the system, right? So you get a V-shaped container here with the length L, right? So you know already the capacitance equal to dm over dp, right? So what you need to find is to find the mass m in terms of P or pressure. M is actually equal to rho V. V is the volume. So if you look into this container, the volume is actually equal to d half dh. Okay, the term d here you need to express in theta. Alright, so to do that, if you divide this into two parts, right? So this one is theta, this one is d over 2, right? So if you calculate tangent theta, it's actually equal to d over 2 over h, right? So if you rearrange this one, you can get a d equal to 2h tangent theta, right? So you insert this one into this equation, then you can get v equal to half 2h square tangent theta, and then you can set out 2, then you can get h square tangent theta, right? So for the volume, and then you insert this into this equation, right? So let's say this is equation number 1, this is equation number 2, so you insert 2 into 1, 2 into 1, so you can get m equal to rho h square tangent theta. We need to replace the h here with P or pressure. P equal to rho GH. Okay, so when you rearrange this, you can get H equal to P over rho G. Say this is equation 3. This is equation number 4. You insert 4 into 3, so you can get M equal to rho P square over rho square G square tangent theta. Right? So rho, you can shut out this one, and you can get P square over G rho G square tangent theta. Alright, so if you differentiate this, because this one is equal to M, if you want to find dm over dp, so you can get 2p tangent theta over rho G square. Okay, so basically this is your capacitance. Basically, the fluid resistance is actually equal to dp over dqm, right? dp is differentiation of the pressure over differentiation of the mass. In some cases, the relationship between P and Qm can be a linear, which is represented by R. And then sometimes the relationship is square root, right? Qm to be equal to square root of P over R. For the laminar resistance in a pipe with diameter D and length L can be represented by using Hagen-Poiseuille formula. This is only applicable for Reynolds number of below than 2300. Then the Reynolds number is given by this formula. Alright, so for fluid resistance, it's similar as resistance in a circuit, where you put in series, you need to add the resistance. If you put in a parallel, you need to you inverse the resistance number. Okay, so let's look into another example. In this example, it's actually want to develop a mathematical model for a fluid system, right? In this mathematical model, you want to find the height h in terms of qmi, in the function of qmi. Alright, so if you look at this system, you got a qmi as an input, and then qmo is your output, right? Okay, so first of all, what you need to do, you need to know that m is actually equal to rho v, right? So this is the basic formula that you need to establish, and then v is actually equal to cross-sectional area, which is a times with h, right? So this is your equation number 1. So m equal to rho a h. Right, so the second equation that you need to know is m dot equal to qmi minus qmo, right? If you further expand it, m dot is actually equal to dm over dt, and then dm over dt could be wrote as dm over dh, and then dh over dt, right? dm over dh you can get from this formula, right? So if you differentiate this formula, d over dh, the equation number 1, you can get rho a. Okay, the next step, you need to find what is QMI and then what is the QMO. So basically the QMI is equal to QMI, and then QMO is actually equal to, if you look at the QMO here, the pressure here is actually equal to the atmospheric pressure plus the pressure from here to here, right? The fluid pressure, right? Basically equal to PA plus uh, rho GH minus the pressure here, which is another atmospheric pressure over the resistance, which is R here, right? So this basically the QMO, right? So you can cancel this one out. You can get QMO equal to rho GH over R. Okay, this one equal to QMI minus QMO. This is equation number 2. This is equation number 3. So you insert no, this is equation number 3. This is equation number 4. Sorry. You insert 3 and 4 into 2, so you can get dh over dt rho a, right? The m over dh is actually rho a, and then dh over dt is equal to qmi, right? Because this one is a qmi minus rho gh over r. So this is basically your mathematical model for this system. Right. So basically, just now we established this equation, right? For the mathematical model, you can represent this using electrical system as well. This the whole part here is actually is equal to m dot. This is the QMI. Then this is the QMO, right? QMO. The m dot here is actually is equal to the m over dp over dt. The m over dp is actually the capacitance. So the capacitance, the whole this part only, right? Equal to capacitance. dp over dt is actually equal to voltage. P pressure is equal to voltage. So then equal QMI is actually equal to current I. So GH is a voltage V over R. Okay. So basically, if you want to represent this into electrical system, those is equal to C dV over dt equal to I minus V over R. I here is QMI. QMI is IS. If you rearrange this, you can get IS equal to C dV over dt plus V over R. And then if you look using Kirchhoff current law, you can get IS and then equal to I. This one C dV dt is equal to IC, right? I in the capacitor. This one is source, and then it equal to I R. Right? So this one must be connected to the capacitor. This one is a current source, and then this one must be connected to the resistor. Right? So that's how you draw the circuit diagram, similar to this one. Okay, now we're going to discuss about Torricelli principle, where it found that if we have an orifice and then the QM is equal to square root of P over R naught, and then R naught is equal to 1 over 2 rho CD square A naught square. Alright, so let's see an example. You have a system attempt that we have a QVI here instead of the QMI. A as a cross-sectional area, and then this one as the total height, and then this here, and then with the L, where there is an orifice at the distance L from the bottom. Alright, so as usual, we got basic formula, which is n equal to rho b, and then d in this case is equal to a. We are not going to use this one because the orifice is at the depth of it. Okay, so the next formula will be m dot, which is equal to qmi minus q and o. But in this input, we got a qvi. Instead of the qmi, we got qvi. Using the same formula here, which is equal to qmi, qm, and qm is equal to rho u. It doesn't matter. If qmi, this one will be qvi. If this qmo, this one will be qvo. Right? So basically using this formula, then you can insert here rho qvi minus rho qvo. So this is equation 1. This is equation number 2. Okay, dm over dh. The m over dh is actually you differentiate this one. You can get rho a. Okay, let's say this is equation 1. So the next step is for you to find these two terms, right? Basically, rho qvi should be equal to rho qvi. So for the another one is the rho qvo. This one should be equal to, if you look into this formula, the qm is equal to square root of p over r naught, right? So basically this one is equal to rho square root of p over r naught. Okay, and then r naught should be equal to this one, the whole thing here. Okay, 1 over 2 rho cd square a naught square. Right, so if you insert here, you can get rho square root of p. You got p 2 rho cd square a naught square. Right? Okay, that's so this is equation number 3. This is equation number 4. Insert 1, 3, and 4 into equation number 2, where you've got dm over dh dot dh over dt should be equal to rho qvi minus rho qv. Right? The m over the h is actually this one. Okay, so basically rho a dh over dt is equal to rho qvi minus rho square root of 2p rho cd square a naught square. If you simplify this one, you can cancel out all the rows here. So you can get a dh over dt equal to qvi minus cd and then a naught square root of 2p P rho. Okay, so basically this is your mathematical model for this system. Okay, so when you have a fluid that is incompressible, so you can use the system as a hydraulic system. So basically, is the conservation of volume is equivalent to the conservation of mass. Let's see another example. So as usual, so the formula that you need to use is M equal to rho V. Then V is equal to A H, right? The M over the H, M over the H. Then you can get rho A. This is equation number 1. So another equation, which is the M dot, should be equal to the M over the H, the H over the T. Should be equal to QMI minus QMO, right? So this is equation number 2. Right, so next you need to find the QMI, which is equal to the PS or PA plus PS, PA plus PS minus PA plus rho GH over R1. Okay, if you simplify this, then you can get you can say PA, you got PS minus rho GH over R1. Okay, so basically this is equation number 3. Then another one is QMO is equal to PA plus rho GH minus is PA, the pressure here, over R2. You simplify this, then you can get rho GH over R2. So this is equation number 4. So you insert equation 1, 3 and 4 into 2. So you can get the M over the H is actually rho A dH over dt equal to QMI is the whole thing here, which is PS minus rho GH over R1 minus the QMO is the whole thing here, which is rho GH over R. So this is basically your model for the system, right? Okay, so this is another one. I want you to solve this one by yourself, right, using the same principle. This is another one.